All right, the test that you're going to take Monday and Tuesday will look very, very, very similar to the study guide. Okay. On Monday, you will have 2 pages. So this is 1 page, and everything on this page goes together. Second page, everything on here goes together. That's what you would see on Monday. And then Tuesday, you will get 2 more, just like that. Okay. There are lots of different versions of this test to try to curb y'all from cheating as much as possible. But when you've had all 4 questions, you will have had one that starts in standard form, one that starts in intercept form, one that starts in vertex form, and one that starts with a graph. Okay, but you won't all get them in the same order, but there will be those 4 types of questions. So you need to know how to start with each of those things and get to everything else. On last Friday, when this was assigned, we did this first page together that starts with a graph. So we're going to skip it for now. And if you have any questions, we'll hit that at the end after we're sure we've gotten through everything else. So I'm going to start on the second page, which gave us this equation in vertex form. Okay, so there are a lot of different ways you can approach these problems. I like to try to get the graph as fast as possible, because once I have the graph, I can get all of these things, and then I'll be able to write intercept form, and then I'll have to convert something to standard form. But once I get the graph, I feel better about it. Okay, I know that you have graphing calculators. In years past, they have not had graphing calculators for this. Okay, if life returns to normal next year, you won't have graphing calculators for geometry or algebra 2. Okay, so I'm going to approach this just like I would have in a normal year, where you have to be able to do all this without a calculator. Okay, so I would have taken this equation and graphed it. What do you have to know first to make a parabola graph? The vertex. So we're in luck on this one because it's in vertex form. So this H and K give us the vertex. But the H is opposite of how it looks. Yeah, so our vertex is actually -4, -8, which means the axis of symmetry is x equals -4. Okay, so I'm going to graph the point -4, -8. And that's going to be the first point on the graph. Okay, and if you remember the way that we graphed these when we did not cheat and use our graphing calculator, became really clear, right? Okay, the way that we graph is we make that move chart. And for the move chart, it was x and ax squared. Y'all remember that? And you got to pick the x's. And I said that picking 1 and 2 are going to be your best bet unless the a value in the equation is a fraction. Then you want to choose multiples of the denominator. Okay, but now we're going to plug what we just chose into ax squared, and the a that you use comes from your equation. So the a value in this equation is 2. So that's what we put here for a. And then we multiply it by the x that we chose and square it. So we would say 1 squared is 1, and 1 times 2 is 2. So what this means is this number tells you your horizontal move away from the vertex, and this tells you your vertical move away from the vertex. So here's your vertex. We're going to count 1 to the side and up 2. 1 to the side and up 2. And since parabolas are symmetrical, you would do the same thing on the other side. Okay. Then we do the same thing, but now we're going to use an x value of 2. The a value still stays 2 because that's the a value from the equation. So it would be 2 times 2 squared. 2 squared is 4. 4 times 2 is 8. So what this says is you need to make a horizontal move of 2 and a vertical move of 8 away from the vertex. So from the vertex over 2 and up 8. From the vertex over 2 and up 8. Okay, when I'm looking at your test next week, I want to see 5 good points on your graph, the vertex and 2 on each side. Okay, if that won't fit, if it had a really big A value here and you couldn't fit 5 points, then 3 is okay. But if 5 points will fit, you've got to have 5 points to get full credit. Okay, so I'm looking for 5 nice, pretty points on your graph. Okay, on your test, each graph is worth 5 points, and you'll get them from the 1, 2, 3, 4, 5 points that I'm going to be looking for. Okay, so we went from the equation in vertex form to the graph. We plotted the vertex, and then we made a move chart to get those other points. Any questions about what we've done so far? All right, once you have the graph, you should be able to fill out all of these key features except the y-intercept. On this one, I can't see where it hits the y-axis. On my graph, I didn't make the move chart far enough. So to get the y-intercept, we're going to have to put it in standard form and look at the c value. So we'll come back to that in a minute. But right now, we should be able to do everything on the key features list except the y-intercept. Okay. On your test, the key features are going to be worth 2 points each. So each one of these things is 2 points. So what are the zeros of this thing? Where does it hit the x-axis? And so we would say x equals -6 and x equals -2. If it would have asked for x-intercepts, you would have needed to written your answer as an ordered pair. -6, 0, and -2, 0. But if it asks for zeros, roots, or solutions, you write them like that. We got the axis and vertex from the equation. We can't see the y-intercept yet. What's the domain? That's it. And then the range looks like this, and we talk about what's the lowest and highest that the graph goes. Lowest it goes is -8. Yeah, goes up forever, so we have an infinity on that side. In behavior? Opens up. And then for interval of increase and decrease, this is where I put the negative infinity out here, the positive infinity here, and then look at the axis of symmetry number, which is -4. And then I say this graph starts out decreasing, and then when it hits the vertex, it turns around and starts increasing. So it's decreasing here and increasing here. So our interval of increase is from -4 to infinity. Okay, interval of increase is from -4 to infinity. And the interval of decrease is from -infinity to -4. Okay, any questions about how we got any of those key features? Okay. Now that we know all of this stuff, writing the equation in intercept form should be pretty easy. So for intercept form, you keep the A value the same as it was in vertex form. And then we're going to use this as the P and the Q in intercept form. But remember, they will look opposite. So this is going to look like a +6 and a +2. Okay, so your zeros, roots, solutions, x-intercepts are going here. and then the a value just stays the same. Okay, and then to get to standard form, we can't just write it. The only thing we know right now about standard form is that it's going to have the same a value that these had, but we don't know the b or the c because we don't know where this thing hits the y-axis. And it's not easy to find the b just by looking at the graph. Okay, so we've got to be able to take one of these two equations and convert them to standard form. So for me, the easiest one to convert is intercept form. And so our intercept form looked like this. And so to convert that thing to standard form, we would multiply these two binomials together. We would say x times x and x times 2, 6 times x, 6 times 2. And we would have x times x is x squared. X times 2 is 2x. 6 times x is 6x. And 6 times 2 is 12. Then you would combine the like terms in the middle to get 8x. And then you've still got this 2 sitting out front that you need to distribute to all of that. And so when you distribute this, you would get, yep, that's it. 2 times x squared is 2x squared, 2 times 8x is 16x, and 2 times 12 is 24. So in standard form, we would have 2x squared plus 16x plus 24. Yep, good. The c value in standard form is our y-intercept. So now we know that the y-intercept is 0, 24. Okay. On your test on Monday, Tuesday, each one of these equations are worth 5 points each. Okay, so you wouldn't get points for the vertex form because it was given to you, but each one of these would be worth 5 points. Okay, and then for the table, we have almost all of these points in our graph. Like the vertex was down here at -4, -8, so that's this point in the table. And then when we made that first move, we were at -3, -6, and -5, -6. So we have those 2 points in the table. The -6 and -2 were our x-intercepts. Okay, so we can see all of these ordered pairs in the graph. The only ones we can't are these. And they're going to have the same y value because of that symmetrical nature of the parabola. So if you calculate one of these, then you would have the other one. So I'm going to take -1 and plug it in right here for x. You could choose any of the equations. This one just looks easier to me because it only has one x and the other ones have 2. So I'm going to put -1 right here and say -1 plus 4 is 3. 3 squared is 9. 9 times 2 is 18. And 18 minus 8 is 10. And that would be the y value for both of those points, because that would be the next 2 points you would have on each side of the parabola. And then that's it. You got the whole page. Okay, so I do want you to know how to do all of that without a calculator, because I think you can. There's no reason to touch a calculator to do that. But since you do have calculators this year, I would check my work. I would go to my calculator and type in all 3 equations, 2x squared plus 16x plus 24, and 2 times the quantity x plus 4 squared minus 8, and 2 times the quantity x plus 6 and x plus 2. Okay, and after I had all of them typed in there, I would check 2 things. Actually, you could probably get away with just checking one thing, but you could graph them and make sure that they all three make the same graph and that graph looks like your graph. You should be able to see it tracing over it 3 times. Okay, so I saw it graph all 3 equations, so I know all 3 equations are talking about the same function. And then I would look at the table and make sure the numbers in the table match up to my table. And if all of that matches up, then I feel pretty good about my answers. Okay, any questions on how to get from vertex form to all of that stuff?
What if there's like the vertex is on the x-axis and you can't write the intercept point?
You would write the same point twice. So if you had a parabola that's set like this, then for intercept form, is that what you asked? You would just do x minus 6, x minus 6. You'd use the same one 2 times. It's a good question. Any other questions so far? Okay, what did y'all's third page start with? Intercept form or standard form? Started with standard? Okay. So standard form is y equals x squared plus 8x plus 15. And we need to fill out everything else. Okay, I know I said I like to graph it first, but for some reason I really want to get this one to intercept form first, just because that looks easy. All you have to do is factor it, which means find 2 numbers that add up to 8 and multiply to 15. So what would be 2 numbers that add to 8 and multiply to 15? So that means our intercept form is going to be x plus 3 and x plus 5. Okay, and I like being able to get it to this form because now I know where it hits the x-axis. So if this is our intercept form, what are those zeros, root solutions, x-intercepts? That's it. X equals -3 and x equals -5. That tells us where it's going to hit the x-axis. So we can go ahead and get those points graphed here. We know it's going to hit the x-axis at -3 and -5. Okay. Then we need the vertex to be able to graph it. So you could use either one of these 2 forms to get your vertex, whichever one you like best. In standard form, you're going to use -b over 2a to get the axis of symmetry. And in intercept form, you've got to use p plus q divided by 2. Okay, so you could use either one of these that you want to use. Anyone have a preference on that? Okay. I like it. To me, it's easier in intercept form, but since they gave us the equation in standard form, we know that that equation is right. And if we made a mistake getting here and then we use this equation, it's going to make our vertex wrong too. So I would go back to standard form just for that reason. So when we have this intercept form, the formula for that is x minus p and x minus q. So those minus signs that are in front of this in the formula mean that whatever we see here is opposite of what it looks like. Just like in vertex form, how that h is opposite. So the P and the Q are always opposite of how they appear in the equation. If they look positive, they're negative. And like on this one, same thing. They looked like they were a +6 and a +2, but they were really a -6 and a -2.
So like, how does the x-intercepts be positive?
No, the x-intercepts, the zeros, root solutions, all of those things are going to be opposite of how they look in the equation. But the way that they are in the equation has to match the numbers up here. Like they have to add to +8 and multiply to +15. So
But couldn't they be positive then? And how do you know that they're negative?
do you mean like could they be negative here and then positive here?
Yeah.
Okay, so if they were both negative, they would multiply to -15. But if we had a -3 and a -5 and we added them, they would add to -8. All right. If our equation was like this, so these two numbers, when we're converting from standard to intercept, they've got to add up to this middle number and multiply to the end number. And -3 times -5 is +15. So it works for that. But if you add -3 plus -5, you get -8. And we've got to make them add up to a +8. So that's why we have to use the +3 and the +5 in the equation, because 3 times 5 gives us that 15, and then 3 plus 5 gives us that +8 in the middle. So there should only be one combination that works for both of them. And then if they're positive here, it means they're negative here and here. That help a little bit? Okay. So we find the numbers that add to this and multiply to this, and that's how we get these. Okay, but to get to vertex form, we've either got to do the -b/2a or the p plus q divided by 2. Okay, and technically you can do either one, but we're going to go back to the standard form because that's the equation they gave us. Okay, so -b/2a. This is your a, an invisible 1, and this is your b, the 8. So it'd be -8/2 times 1 to plug in the 8 and the 1 into this formula. And so then it would be -8 divided by 2, and -8 divided by 2 is -4. So -4 is our axis of symmetry. And then we have to plug that back in for x to get the y value of the vertex. Okay, so the equation looks like this. And we're plugging in -4 for x to find the y value of the vertex. This would be 16. This would be -32. When you combine those, you would get -16. And then when you combine those, you would get -1. So your vertex is -4, -1. Okay. The vertex is -4, -1, and the axis of symmetry is x equals -4. Okay, and we found that by doing -b/2a from standard form. And if we know the vertex, now we can write vertex form. This is going to look like a +4 when you plug it in, and then a -1 at the end. And the a value would just stay an invisible 1. So it would be the quantity x plus 4 squared minus 1. Okay, so now we have vertex form. and we know the vertex, and we can graph the vertex down here at -4, -1. Okay, and by graphing the x-intercepts and the vertex, we have 3 points, but we really need 5 points. So we need to make that move chart to get the other points. And I'm going to always use a move of 1 and 2 unless the a value is a fraction. But we already have the move of 1 graphed when we did the x-intercepts. They're 1 over from the vertex, so we don't have to work that out. But we would do the move of 2. We would use the a value from the equation, which was 1, and then plug in a move of 2. And we would say 2 squared is 4, 4 times 1 is 4. So this tells us that we would make a horizontal move of 2 and a vertical move of 4. Okay, and that move always happens away from the vertex. So we would come to the vertex and go horizontally 2 and up 4. And we would do that on both sides because parabolas are symmetrical. And then there's those 1, 2, 3, 4, 5 points that you need to get the full 5 points on that part of the question. Okay, and then we should be able to fill out the rest of the key features. Again, we can't see the y-intercept on the graph, but that's okay because we have an equation in standard form. And the equation in standard form, the c value is your y-intercept. So our y-intercept would be 0, 15. The domain would be all real numbers. For the range, we would have the y in the middle and have that stuff. And we need to tell lowest and highest. The lowest it goes is right here at the vertex, -1. And the highest, infinity, goes up forever. In behavior, opens up. And then for interval of increase, decrease, that's where I put the negative infinity, the positive infinity, and then look at the axis of symmetry, which is -4. And I'm going to say it's decreasing at first, and then when it hits the vertex, it's increasing. So the interval of increase is between -4 and infinity. And then the interval of decrease is from negative infinity to -4. Like that. Okay. Any questions so far? Yep. Mm-hmm. All right, and then again, most of the points in the table we can see on our graph. The point -4, -1 was our vertex. Then -5 and -3 were our x-intercepts, so they have a y value of 0. Then we used our move chart to get these points. So that's -2, 3, and -6, 3. So again, there's only one y value that we don't know because these have to have the same y value. So if we calculate one of these, we would know both of them. So I'm going to put in -1 for x right there and work it out. -1 plus 4 is 3. 3 squared is 9. 9 minus 1 is 8. So those two would have to have a y value of 8. And I like to always look at my graph and see if that looks reasonable. If the point -1, 8 would be on the graph, and -7, 8. And that looks reasonable. My graph isn't perfect, but those look reasonable answers. Luke?
It says it's like 150 points.
It's actually going to be 152 points. It's kind of random, but that's just when I did.
Each part is?
The whole thing. 76 and 76. When I did 5 for tables, 5 for graphs, 5 for equations, and 2 for these, it worked out to 76 points on each half, 152 total. Okay. Any questions on this one that started in standard form? All right, one to go. This one starts in intercept form. So if it starts in intercept form, the thing we know is the x-intercepts. Okay, so the x-intercepts are going to be the p and the q, but they have to look opposite, or they are opposite of how they look. So our zeros would be +2 and -2, and we can go ahead and graph them here. Okay, and what we know when these are equal distance from the origin is that our graph hasn't been moved sideways at all. It's going to be centered around the y-axis. Okay, so we know it hasn't been shifted off to the side. We know the vertex has to sit somewhere on the y-axis. That's going to be the axis of symmetry. To actually calculate the vertex, that's where we would do p plus q divided by 2. And so the p and the q are 2 and -2, p and q. So we would add them and divide by 2. That would be 0 divided by 2, which is just 0. So our axis of symmetry is x equals 0. And then we would plug that in for x to get the y value of the vertex. So that would look like this. We would have -1/2 times 0 minus 2 and 0 plus 2. And 0 minus 2 is -2, and 0 plus 2 is 2. Then if you multiply those two together, you get -4. And then -1/2 times -4 is +2. So that tells us that our vertex is 0, 2. Okay, so we could go ahead and plot that point right there. It's going to be your vertex, and it also happens to be the y-intercept. Okay, and once you know the vertex, you can write the vertex form equation. It has to have the same a value as this one. So that's going to be -1/2. And then we would just plug in this vertex. This is going to be your h and your k. So we would have x plus 0 squared plus 2. Okay, so technically this is what your vertex form would look like. If you wanted to simplify it, you could simplify that 0 out of there. And when you simplify the 0 out, it would look like that, because x plus 0 is just x. And then when you get it to this form, that's actually your standard form. So you don't have to do any more work to get standard, because when we simplify that 0 out, we just have it. Okay, for vertex form, I would accept either one of these. You can leave the 0 there, or you can simplify the 0 out. And in that case, your standard form and vertex form would be the same. And that's okay, because when you have a parabola that hasn't been moved off to the side, you really don't need a vertex form. If it's centered in the middle, the vertex form isn't needed, because then your y-intercept and your vertex are at the same place. Okay. To finish our graph, we need a move chart to help us get 5 points. Right now, we only have 3. And we've said that you want to pick 1 and 2 for your moves unless the a value is a fraction. And when your a value is a fraction, I pick multiples of the denominator. So I would pick 2 and 4. But because we knew the x-intercepts and they're 2 units away from the vertex, we don't need to calculate that one. We just need to do a horizontal move of 4 to get the next points. So you use the A value from your equation, which was -1/2. And then you plug in the move that you chose. And then you work this out. So you would say 4 squared is 16. 16 times -1/2 is -8. And what that says is when you make a horizontal move of 4 away from the vertex, you need to go down 8. So a horizontal move of 4 and go down 8. Horizontal move of 4 and go down 8. And then you have the 1, 2, 3, 4, 5 points that you need on your graph. And then we should be able to finish our key features. The domain would be all real numbers. For the range, we need to tell lowest and highest. This one goes down forever. What's the highest that it goes? Yep. Highest it goes is 2 in behavior. It opens down. For interval of increase and decrease, we'd have -infinity and positive infinity. And then we look at the number of our axis of symmetry, which is 0. And we say this thing starts out increasing and then it starts decreasing. So our interval of increase is from -infinity to 0. And our interval of decrease is from 0 to infinity. Okay, and then all we have left is the table, and most of these points are in the table. This 0, 2 is the vertex. -2 and +2 were the zeros. 4 was at -6 and -4 was at -6. So these are the only two that we can't see from the graph. And so we could take this x value and plug it into one of our equations. And that would say 6 squared is 36. 36 times -1/2 is -18. And -18 plus 2 would be -16. And so that would give us our last two y values. And that's it. Any questions on that one? Any questions on anything on the study guide? Any questions about what's on the test? Any question about when is your test? Any question about how many points the test is worth? Yes. 152. 76 points each half. Okay, you will probably have this test, and then we're going to learn the 5 different ways to solve quadratics, and you'll have a big test on that. And those will be your 2 big grades this 9 weeks. Everything else will be quizzes or daily grades. Okay, you do have the Socrative assignment that's due Monday at 8:15. You need to work through it once to get your daily grade of 5 points. If you work through it and get a 100, then you earn the bonus points on the test. That's it. No questions? Concerns, fears, deep dark secrets? Okay.